Okay, welcome back. So in the previous module, we talked about an H parameter model for the BJT. And on your screen, you see that this is your H parameter model. And generally, we use the H parameter model for a low frequency analysis and also high frequency analysis. So for low frequency analysis and high frequency analysis, we use that. For high frequency, you need to incorporate the capacitances into the model. And we see that there is an input voltage and output voltage, input current, output current, and BJT is a three-terminal device. Therefore, you have pin 1, 2, and 3. So that represents now HIX represents the input impedance, HOX represents the output impedance, HRX multiplied by the output voltage indicates your reverse gain. That is, you feed the model or socket from the output side and you record the input, record the output from the input side. This is your forward gain that you do that. Now, the question here is, we saw this for the common emitter case earlier. What about we want to understand the parameters for other two remaining configurations, such as your common base and common collector. So we are going to write that in a moment. So what you did for a common base, this circuit will be modified as pin number 1 is your emitter. Let me use the different color of pen, that will be better. So here it will be your emitter. Let's do it in a proper way so that representation matters. We'll do that. So this is your emitter. This will be your base. This will be your collector. So this is, we are talking about the first case, common base. So the input voltage will be your VEB. That is your input voltage. Then current II will be equal to your emitter current IE. That is your input current. Then you have output current IO. This is your collector current. This is your output current. Okay. Now, HI and X will be replaced by B because we are talking about common base. So HIB. We'll say that this will be input impedance. Impedance of your circuit. Then you have HOX. That will be replaced by HOB. This is your output admittance or output impedance. Admittance. Then you have HFX, which will be replaced as HFB. This is your forward current gain. Current gain. And it looks like my keypad is not working properly. I need to replace that. Or maybe a lead of the keypad, the pin that I need to replace. Then you have output voltage, which will be your VCB. So that is your output voltage. And finally, you have H R X, that is HRB again, and this is your reverse gain. Reverse gain. It's like the signal is coming from the output side, and you receive it in the input side, and whatever the gain gets, that is your uh, right. So that's all. So you have this model for your common emitter, common base configuration. Usually we say that the output impedance, which is a reciprocal of the output admittance, which is HOB, is in ideal case is infinite. Okay, and HRX, which is a reverse gain, is ideally zero. We say that we assume that there is no reverse gain, we only have a forward gain. In that situation, your model is translated into a simple one. So you have like this is your HIB, and that's your positive, negative. Now this you don't have it now because you said HRX, which are HRB is zero. So it's pretty simple. So you just have it like this, and you have this input current IE. This is your emitter and pin number 1, and then all you have is just a forward current gain, which is represented by this current source. And this guy is nothing but your output current IC in number 2, which is a collector, because output admittance is a 0. And this is all here. And here is your VCB, your output voltage. And that's your common terminal. This is your common terminal. You say that this is pin number 3, and that is your base. And this is your HFB times IE. Okay, so IC is your HFB times IB, sorry, IE, and therefore IC over IE, which is a ratio of the currents, and this is B, HFE. Okay, so for AC small signal analysis, you write the small letters for FB, but for a DC analysis, you write F and B or capital letters, and this is your current gain. That's it. So you see, this is how you actually make your model. What about you want to draw the model for your common collector configuration? Can you do that? So let's try that. Your pin number 1, common collector, you have this HFX. Is it HFX? No, HIX. This is your HIX. Then you have a reverse gain, a voltage gain, reverse voltage gain, which is HRX times VO. Was it the output voltage VO? Yes, that is VO. And here you have a forward current gain, which is your, this is pin number 2, and you have, this is your output, and this is your pin number 3. So for a common collector, you have C, which is a collector here. Input is your base, and output is your emitter, right? That's true, that's true. And the input current I1, output current I2, this will be your HFX times I1, that's your current, and this is your output impedance HOX. So we'll write that. So here your input is VI. Is that correct? Yeah, VI, VO, everything seems perfect, and we got the naming convention. So this is your model for the common collector. Common collector. So CC. CC. And now what you see here is your input voltage VI is your VBC. That is your input voltage, right? Then your input current II is your IB. Right, this is your input current. Then your HIX is HIC. X is replaced by your C. Letter C indicates a common collector. So this is your input impedance. Then you have, let me write here, HOX. It is HOC. This is your output impedance or admittance. Just take a reciprocal of the admittance. It is actually output admittance. Take a reciprocal of it, becomes impedance. Then you have HFX, which is HFC, and this is your forward gain. And then you have HRX, which is HRC, is your reverse gain. This is current gain actually. Current gain, and this is voltage gain. Okay, and this is the reverse voltage gain. And finally, you see that your output voltage V, which is VEC actually. VEC, which is the voltage across emitter and the collector. So this is output voltage. So you actually can see that your I2, we haven't seen what is I2. I2 is your emitter current, IE, which is output current. And what you see here, your I2 over I1, which is your emitter current divided by the base current, becomes your HFC, which is your gain, the current gain. So ratio of IE over IC is your current gain. So that's the model for your common collector. And with admittance, to be 0 and the reverse gain or the impedance to be infinite and the reverse gain to be 0 in ideal case, you can simplify the model for this one. Okay, so we got this for the common collector. This is for the common collector, and up here is for the common base. And we have seen that in a previous module how to derive the H parameter model for a common emitter also. So hope you understood the basics about it. If you like the video, click the like button, share it with others, hit the subscription button for the channel, and I wish you happy learning. Stay tuned.